Alright folks, we have made it to the very last practicum for ANT 562, Archaeological GIS and Geospatial Technologies in spring 2025. I want to apologize for the state of my voice and if I occasionally cough during this, and also for the lateness of this practicum. I got sick the other day after class and it's been a rough couple of days, but I'm going to get this recorded for you today. So firstly, this is the project file for project 4. You can see there's some stuff that I've sort of struck out. We talked in class about having the option to either do the airborne LiDAR drone photogrammetry or the object photogrammetry 3D modeling. And just to simplify our lives, we're just going to go all in on the object photogrammetry. And we're going to basically take the laser scans and the photogrammetry scan that we did of the Samuel T. Black statue on campus the other Monday, and we're going to use those data sets for this particular project. So firstly, in terms of the background, you can click to get some more information about who Samuel Black was, first president of SDSU, and then a little bit more information on the particular LiDAR scanner, the Livox Avia, in the photogrammetry app that we use, Reality Scan, which you should check out. You want to include some of that information as background in your report for Project 4. If you click on the link, it will open up the Google Drive. There are 2 zip files. You're going to want to download both of them. Just sort of right click and download on them and save them somewhere sensible on your hard drive. I have a little folder in my documents called 3D Data, and then you just want to make sure that you extract both of those things into that folder. So inside the LiDAR folder, you'll find 3 .texts. These are the 3 scans that we did. Angle 1, angle 2, and directly from the front, as well as the JPEG photograph that we took from the front of the statue that, if you want, you can use for texture to drape over that statue. And then in the photogrammetry, you'll have 3 files together, the .obj, the .obj.mtl, and the .jpeg. The .obj is the actual model, and the rest of these things are for the texture, the imagery that overlays the textured mesh that comes out of that routine. So those are the base data, and then we are going to be working with CloudCompare, and you need to download CloudCompare. So just put in CloudCompare. You can see I've been searching a lot. CloudCompare into your Google search bar there. And you can either click on the main project window, or for me anyway, the downloads comes up here, and there are installers. So do not install the alpha. Okay, go down to where it says latest stable, and that's the one that you're going to want to install. So you have your Macintosh, you have your window. Now there's 2 Windows, and I'm not sure which one makes the most sense, but I'm going to guess it's this 213. I'm obviously using Linux, so I'm using this particular one over here. So one confusing thing for me is that, in fact, I just noticed I still have the old version of CloudCompare installed on my computer. So I have to make sure that I open the latest one. It's really important that you get the latest version, because some of the tools, like the plugins, for example, are not going to be available in even like the most a fairly recent previous version. So let me wait for that to open up here, and once it is open, we can proceed with the steps in project 4. Okay, so now that I have the right version of CloudCompare open, we can get started. So this is the interface over here, and probably the easiest way is for you just to jump in. Let's go to the File, Open menu, and once that pops up, you need to navigate on your computer to where you extracted your imagery. We're going to start with the LiDAR data, so that's what we're going to do. And you may get into it and it doesn't show anything, and that's because it's by default looking for the .ply folder. So if you click down here, you can either hit all or ASCII. ASCII is again text. So now we have all 3 of them. Let's import all 3 of them at once. You can do it one at a time, but it's straightforward enough to open all of them at once. You'll get this import dialog, and you need to make sure to separate a couple things, because ASCII can have a variety of different separators. We need to confirm that we get the columns dividing the way we think. Here, comma is right, and we could swap in any of these other characters if our particular data files were formatted that way. But comma is good for us. We do need to see that we have like one row at the top which are headers, so we need to skip those, but it does give us a chance to verify that X and Y and Z are in the right order, and that the reflectivity value, which is basically the strength of the laser return, is in the scalar column number 4. Now I've cleaned these up, so the raw data out of the LiveVox has a whole bunch of extraneous columns that we don't need. These are the ones that we're going to focus on for today. So I've already done that step for you, but if you were to work with this data in the wild, you might have to deal with more columns than this. And everything else should be okay. We're going to hit apply all, so it does this to all 3 of those files, and we'll just go through them one at a time, and it will import them. And by default, it's going to stack them all up from the same viewpoint, even though we moved the LiDAR unit between them. And so we basically have this like wedge shape that you see here. That's basically the angle of view from the LiDAR sensor, and it's looking, I guess, that way on your screen. So we're going to deal with these one at a time. So up here you see the individual layers, and they're kind of nested. So this is the like actual container, but the data, the vertices below it show up nested over here. So you can actually have multiple sets of vertices sort of nested within a single container. But in our case here, we have 3 containers, each with only one set of vertices. So we're just going to uncheck the top 2 so that we're basically just looking with the front of the statue. And to make it a little easier to see, I'm just going to open this up a little bit so that we can see what's going on. Now in CloudCompare we have, this is basically the same thing as our layer manager in GIS, and then over here we have a properties dialog, which we'll get to in a little bit. We have some tools that are accessible as buttons all around the outside, and then we have some menu items over here. So I'm going to just bring the project file up here because I want to show you how I mention where to go. So sometimes I tell you to do that, and other times if it's easier to click the button, like somewhere down here when they're talking about segmentation, I talk about the one that looks like a pair of scissors, right? So I will do this sort of either way depending on what is the most sensible. But for example, here's a segmentation tool that looks like a pair of scissors. So when you're reading through the project file, that's basically what I'm talking about, okay? And it's important that you have the right layer or the right bit of data highlighted, because whatever you have highlighted is whatever you're going to actually end up editing, okay? So our first order of business, now that we have our data in here, is to actually clean out everything that is not the statue. Now I'm using a regular 3-button mouse here. If you're using a trackpad, this may be funny because you have to use the right click and the scroll wheel plus a few keyboards presses of like Shift and Control or Alt sometimes in order to interact with CloudCompare. So by using the scroll wheel, you can zoom in. By clicking on the left mouse button, you can grab and rotate in any direction. And you can see when you do that, you get this sort of 3D interface. And it's a little bit weird at first to see like where you need to click and grab, but imagine, see that circle, that globe that pops up? You're basically grabbing that globe and twisting it. So where you grab it kind of matters for how it's going to respond when you then move the mouse after that. Now if I click on the right mouse, I can actually reposition the actual point cloud in relation to the screen that we're looking at here. So we have a couple of things going on here. We have the center of the screen, but we also have the center of rotation. To make our lives a little bit easier, what I want to do is to put this into an orientation that is a little bit easier to see. So by default we were looking kind of straight down at it, but now if I turn it this way and I reorient it so it's sort of in the middle, you can basically see from the perspective of where we were standing where the actual statue is. So most of it is actually background noise that we want to remove. This is the building, this is some of the trees. Remember the shadow we saw of the statue in the LiDAR imagery? And the statue itself, oops, see, sometimes it's a little bit weird. You gotta zoom back out and grab it. Reorient it. I grabbed it in the wrong spot. The statue itself is right here. Okay, so just to keep it from doing that, what we can do is click this Pick Rotation Center button and put the rotation center right there in the middle of the actual statue base, and now it won't respond in such a weird way when we're rotating it around. Okay, so what you want to do is to orient it so you're looking kind of down on it and put it sort of in the middle so that you can zoom in. So this is like a pigeon's eye view of the actual statue, and kind of get it rotated, because what we want to do is to clip out everything that is not the statue, because we actually don't care about that for our purposes here. So to do that, what we're going to do is to select the segmentation tools, and this is basically like what it looks like, a pair of scissors. What we're going to do is to draw a box, and we're going to cut out everything that's outside the box. So after we've making sure we've got our front of statue selected, and we have that, we have our little segmentation toolbox, we can click around it, and then to close this, it's a right click, and now it's ready to go. Now just to notice up here in the toolbox, if you hit pause, then now you can reorient it, which is sometimes useful, but until you hit pause, every click that you do is actually going to start drawing your box again, right? So if you mess up, just after you right click, you can just start drawing it again. And you want to make sure that you've got the thing oriented right, because see how his head is missing right here because the angle's not directly down on it? It will clip that part of it out in 3D. So it's a little weird. I'm going to hit pause again, and I'm going to reorient our statue so that we're more or less looking straight down. And now I'm going to redraw our box, okay? And I'm going to give a little bit of leeway around it. It's okay to have a little bit of leeway around it. So you got two options, segment out or segment in. And we're going to segment in to basically keep what's in the middle and get rid of what's out there. Now this isn't permanent yet. If we don't like this, we can hit the X here and it will undo it. But if we do, we hit the checkbox and you're like, wait, it didn't do anything, but it did. It actually segmented it, split it. This is a safer way, instead of completely deleting everything, right, immediately. It just splits them apart. And now what you can do is to see which part has been segmented out and which part has been removed, right? So this is the part we want to get rid of. We'll right click it and we'll delete it now that we are sure that it's gone, okay? So at this particular moment, what I would do is I would do the next one, sorry, like so, and you'll see that because remember the LiDAR unit was at a different angle, we're still looking down on the statue, but we need to rotate it a little bit that way. So let's grab our handle over here and rotate it a little bit, and again making sure that angle 2 is selected. We're going to now segment that one in a similar way, and again give it a little bit of leeway just to be a little bit safe. Segment out, we're happy with that, and then just click and unclick the checkbox of the one that you selected to make sure it's correct, and then delete. Okay, and now we go to the last one over here. In this case, we're looking at it from the other side of the statue, the other angle. So we're just going to rotate it again till we get our view basically how we want it. And we're going to select that, and we're going to segment. By the way, if you don't have anything selected, these tools will not be available to you. So you kind of are forced to select them properly. Okay, segment out, looks okay, check mark. Then we'll verify that this is the one that we want to delete. Okay, so now we can open them all up, and you can see they're all kind of stacked on top of each other because they're about equidistant in the LiDAR point cloud reference but the angle of view is different on all of them, the angle from which we were recording it. So now our job is going to be to align them all. But before we do this, we probably want to save out these guys in case our, in case our program crashes on us, right? Because there's not going to be any sort of undo redo. So you just want to make sure you have this guy, this level here selected, and then you go to where it says Save Current Entity, and just in our LiDAR, and you might want to have a new name called I don't know, cleaned or something like that, and this will be the front of statue, and you can save it as a PLY for now if you would like. That's fairly standard, and hit save. And then we'll do the next one, and after it does this, it'll take a little while. Oh, well, save it as ASCII or binary. Let's go ahead and save it as binary to save a little space. And then we'll do the next one. Whoops. Save that entity. This will be angle 2, and it will be .ply, binary to save a little space, and then the last one. Whoops. I keep hitting right click on it. Okay. Angle 2, angle 1, sorry. And binary. Okay. So now that we have those backup copies, we can restore, if our program crashes, we can at least restore them to this point and save everything that we have done. So let's work on registering them. Let's start with the front of the statue as our reference. So let's rotate it around so that we can actually look at it and see how it looks. And then if we look at the other angle, we can see, they're close enough together, but we have to move them. There are a couple ways that we can go about this, or there's a couple steps in this. We have to roughly align them, and then we'll have an automatic routine that finally registers them, and then we can meld them all together into a single cloud. So we have to work in pairs, and we will use one as our reference that we move the other ones to match. So since the front of the statue is a little bit clearer and matches the two side angles, that's going to be the easiest one for us to be our reference. So I will show you initially a straightforward way where we do point matching, and then I will also eventually show you how you can kind of manually move them, which is a little bit harder, but sometimes you have to do it that way as well. So highlight the two ones that we want to register, and then we go to Tools, Registration, and then Align Point Pairs Picking. So this lets us choose which one to be the registered, or to be aligned, and which one, the other one will be the one that stays stationary. So we're going to select angle 2 as the to be aligned, and then we're going to click OK. And we get this little box over here, and we can now see just the reference, and we can see the to be aligned. So we want to look at the reference, and what we're going to do is pick pairs of points that we can match up between them. And you can zoom in and rotate and move, translate and move around. So it's very useful to kind of get a sense, firstly, which one of these points. And for this particular view, I think the corners of the pedestal here are going to be the most straightforward. So let's start with the reference entity, and we know that the angle of view is coming from this other side. So this corner, this bottom corner, and perhaps this far corner, we need at least 3 points to match up. So let's just sort of zoom in so we can get pretty good where the corner is, and we just click there, and it'll pick a point in this area, and it'll say R0. Now we uncheck reference and check aligned, and we zoom in on what we think is the same point, recentering and zooming in, and it's going to be somewhere in this area here, so we can click on it. And we should now be able to see the reference 0 and the A0 over here. Now we don't get any statistics until we get at least 3, right? So we got to pick 2 more points. So let's keep going. Let's do the bottom corner over here where the pedestal sort of meets the ground. And it should be somewhere right around there. And now we're going to see the aligned image, and we're going to zoom in to basically the same place. It's sometimes useful to get more or less the same angle of view, and click on them like so. And we need at least one more, so let's go ahead and sort of reorient ourselves to this far corner like so. So we could choose this corner, or we could maybe choose like this point over here, but the sort of greater spread you have, probably the better chance of it being a good, rough registration. And remember, this is the rough registration. The routine will automatically more finely adjust all of this going forward. So this one's a little bit hard to see, but it's about right there. You can see how the blue color is changing a little bit over there. So that is kind of the corner that we're looking at. And so now we're pretty good to go. We can see both of them, and we have pretty decent small errors over here. We could add more points, but honestly, if you add more points, you're probably going to get a worse fit, because we're not being super exact here. We just need to get it roughly aligned. So you're going to leave everything checked. It's going to rotate and adjust everything. You don't need to adjust the scale, because that is going to be the same, because we're using the same instrument. If we're aligning different things from different sensors, and I'll show you that in a little bit, we will have to do that. Check that button. For right now, we hit align, and we get to see the two clouds pretty well aligned, right? So they're not merged, they're just aligned. So we hit check, and it says what it did, and we're okay. And so now all we have to do is to do the last two pairs. So we select front statue at angle 1 now, and we're going to basically repeat the same thing. Go to Tools, Registration, Align Point Pairs Picking, and making sure that we pick angle 1 as the to be aligned entity. And we're essentially going to go ahead and choose matching pairs. So I'm looking at the to be aligned, and we can basically see these three, at least these three right here, 1, 2, 3, basically the same ones that we picked before. So we're going to go ahead and do the same thing. Let's move it and zoom in until we find the first little corner, and I'm going to do this fairly quickly this time around, since we did it slower the first time. And again, we just have to be, we want to be pretty accurate, but we don't have to be perfect on any of this. Just got to get, this particular object is pretty easy, because the square corners kind of really help us figure out what we're looking at. And you could probably tell that if we didn't have square corners, it would be tough. In which case, we would have probably wanted to set out calibration targets. These are little plus-shaped markers, like little stickers or something of that nature that we would attach to the object that we were scanning, that would show up in the 3D data, which is really important, and that we would use to as our registration marks. So let's go ahead and hit align. We have a little bit bigger errors, but not really very big errors, and it looks pretty good, in fact, when we're putting them together. Again, this is the rough align, and we can hit check mark and click OK. Okay, so now that we have done this, what we're going to do is do the fine automatic adjustment of the angle 1 and angle 2, keeping again the front of statue as the reference image. So in this case, the order that you select them matters. I believe we have to select the to be aligned first, and then hold down the control button to click the second one, which will be the reference image, front cleaned. We'll go to Tools, Registration, Fine Registration. And actually, it looks like you can swap them. So to be aligned is angle 2, and statue front is clean. Now if I did it wrong, I could hit the swap button and it would switch them, but we want the front of statue to be the reference, and we want to move the angle to. And in this case, we're just going to leave everything the same, all the defaults the same, and click OK. And it will do its thing, and it will finally adjust them like so. We made one mistake, actually, in which case I should have told you that what we needed to do, let's try that again. Okay, let's try that again. I made one mistake here. Registration, find registration. Is the number of overlaps should not have been 100%. It should have been about 80% because they're not the exact same angle. So 80% of the one cloud is going to overlap with the other. So we'll click OK. I may need to go back and do the rough registration, but it looks like it did OK. Okay, so I could see that the yellow and the red were not quite registered. So very important to change that number. Let's go ahead and now do the angle 1 and the front. Same deal. Registration, find registration, making sure that the front of statue is the reference, and 80% is about right for that overlap. So we click OK. You may have seen me kind of freeze up there, but it doesn't take that long. It took just like 10 seconds or so on my computer here. So now all of our clouds are finally registered, and we can actually merge them together. You could, at this moment, save these out individually, probably a smart move, but I'm going to risk it, and I'm going to go ahead and merge them all. So I'm going to go to Edit, and I'm going to go down, firstly I'm going to select them all, holding the Control button to select multiple. I'm going to go to Edit, and then I'm going to go to Merge. And I do want to generate this scalar field that just tells me which cloud was which at the end. And there we go. So at this particular moment, I'm going to save out the entity as merged full cloud and hit save. I'm going to just do it as a binary, okay? And so here's the point where I'm going to talk about scalar fields, okay? So right now the colors are related to the scalar field we just created, which is which cloud was which. So the points that are green are from angle 1, the points that are probably red are from angle 2, and the points that are blue were from the front of statue. And the merged cloud has points from all three of them. And in the properties dialog over here, you can see if you wanted to have no color at all, the dots are just white, right? So we can choose scalar field, but then we can choose which scalar field we want. We have the reflectivity, which is the data that comes directly out of the LiDAR, and it is related to, again, the darkness or so, or brightness of the actual point where the laser bounced off of. And we can change the size of the points to bigger if we want it to look more full, for example, and we can also change the color scale. So if we choose gray, we get actually a nice little gray scale, but we can choose, like there's all these different color scales, just like in GIS. Viridis, yellow to brown, whatever you like, right? The more colors, the more gradations theoretically that you have in there. And of course you have a histogram down here, but you can also go to Edit Scalar Fields, Show Histogram, and see a bigger copy of the histogram here. And whatever scalar field we have reflected here is what's going to show up in the histogram up here, reflectivity value. And that's pretty good. Okay, so at this point we have our merged cloud, but you can see we have still some cleanup to do. So we can either manually clean or automatically clean or do a little bit of both. So I'm going to show you how I would go about manually removing a bunch of this vegetation, and I'm just going to making sure this is selected. I'm just going to use that segmentation tool, and I'm just going to go kind of a little bit outside of the statue and the pedestal, and I'm just going to like manually select that whole region, and I'm going to do the segment out, and then I can see that that stuff there is, I don't want it, and I'm going to delete it. I'll do, you can rotate this a little bit, but I'm going to try and get rid of some of this floating veg from here. So I'm going to go ahead and segment that out as well. And again, remember, if I hit pause, I can rotate it a little bit, just see what I'm dealing with. So I don't want to remove too much of the statue, but I definitely want to get rid of some of that floating veg. So the angle that you view kind of makes a difference. So in this particular case, because I want to get rid of some of these floating points that are over here, I'm going to do like so. And then, I can kind of try and get in like this and get rid of some of them. And segment out and make sure that's the one that I want to delete. And then, of course, I'm going to rotate it around to the back and see about getting rid of some of this vegetation here. And the reason why it's probably important to do a little bit of manual pruning here is because the automatic tools will just work a little bit better if you get rid of some of this sort of grossly, out of bounds stuff that you don't really want at all. Okay, so now we've got that mostly deleted, but you can see there's still some in there, and you should probably take your time. You can zoom in and see about placing the center of rotation somewhere a little bit more, amenable to rotating it around. See all these points sort of floating out here? You might as well try and get rid of those. So I'm going to do that real quick since we're zoomed in here. I'll just show you real quick, just like so. Now, this particular scan, for whatever reason, it turned out to be, actually quite noisy. I think it has to do something with the reflectance of the bronze. So a lot of the statue itself is not the finest scan that I've actually seen this scanner do. So it pays a little bit of dividends to remove some of that stuff. Okay, so now we have a sort of manually cleaned one. And again, if you weren't living dangerously, you would want to save this out as a PLY, which I'm actually going to just go ahead and do. Merge cloud cleaned one. And now what we're going to do is, selecting this, we're going to do some automatic filtering for noise removal and to clean it up, and then we'll reduce some of the number of points just so that we have a fairly even density of points. So we're going to go to Tools, and we're going to Clean. We have a couple different filters. This is an outlier filter and a noise filter. They work similarly, but they produce different results. I would suggest starting with the noise filter and leave the defaults. Click Remove Isolated Points and click OK. And it'll take a little while, and you'll actually see a new one. The original is here, and the cleaned one, and the original one is still there but is unselected, and the cleaned one is here. And here we're looking a little bit better. Obviously, every time you clean, you're removing points, and so you're going to end up with a slightly less dense cloud. So you have to kind of go back and forth and make sure you're okay with what has been removed. And, if you want to remove fewer points, what you should do is highlight again the original cloud, go back into the Tools, Clean, Noise Filter, and you can change these two values. So this is the millimeter sphere that it's going to look for. If you want to remove more, you can make that number bigger. If you want to remove fewer, you can make it smaller. And click OK. And then we can see like so. And I may have told you exactly the opposite that you were supposed to do. Make the number bigger to remove fewer. Let's try that again. Let's try making that all the way 1 order of magnitude fewer. Yeah, that is the correct thing. So to remove fewer points, you make that one bigger. And that looks actually okay. It's looking pretty good. removing noise. You know, there's still some stuff here that the laser couldn't see from the front angle, so these are probably best manually clipped out. So clicking our segmented one, and then, you know, just kind of going in there and you know, putting in our little outline as best we can, knowing that we're not going to be perfect in here, and segmenting those out. And then just double checking, delete. So you can spend a little bit more time on that than I did. The other one is the outlier, spatial outlier removal, and it's better to remove some of those particular outliers that are floating in there. So let's try and see what that does at the default. And it does a pretty good job. You can kind of see which ones it removed, so it did a pretty good job. And going back to the prior one, we can try changing some of the parameters. So, you know, either reducing the threshold or perhaps increasing or decreasing this number will get you a result closer to what you're looking for. And just to sort of flash back and forth, it looks like the lower number was better. So let's go ahead and try that one last time. Oops, making sure we just have the original one highlighted, clean, outlier removal. So let's just go ahead and put 4 there and just see what it does for us. It doesn't seem to have changed too much. So this last one here is the one that we want to keep. And so let's go ahead and save that one out. And cleaned, I'm just going to call it cleaned final. Okay. So at this particular moment, we are on we just finished step 7, and you can decide to do step 8, which is to subsample, but we want to know whether or not that makes sense. You know, we've already removed a whole bunch of points, so somewhere here, points. We have about 1 million points here, and you know what we want to do is to see if it makes sense to subsample. And really what we want to do is just to make sure the density is relatively even. We don't want too many points in one area but not enough in another. So what we'll do is to go selecting this cloud, we'll go to Edit and we'll go to Subsample. And what we want to do is to change the minimum space between points. And this is going to be in meters. So we want to make sure that we are doing this correctly. And a good rule of thumb is to set it for about half a centimeter at first, right? So that we have 1 point every half centimeter. You know, we might want to go a little bit more. If you're going to mesh this, the fewer the points, the faster the meshing is going to go. So this is called decimation or simplification of the point cloud. So let's go ahead and do that. And we now have the new one, and you can see we have only 223,000 points. And it looks like, you know, we still have good density around the whole thing. So we can go back to the beginning, and then we can go back to Edit, Subsample, and choose a slightly smaller value. Let's try like 0.25, so every quarter centimeter. We can just go ahead and do that and see what that one might look like when we select it. And that one has 500,000 points. So that might be a good compromise to thin it out just a little bit, but still retain a good density of points. So I'm going to go with that one, every 0.0025 meters. We're going to save a point. And so now we're going to save that one is you know, our final simplified point cloud. Okay, and we're going to save that as a binary. So I'm going to remove remove this other one. I'm going to keep the original denser one just so we can see a comparison when we do some stats, which is what we're going to do next. What we're going to do is to firstly now compute the normals like I talked about in class. That is the line that is perpendicular to the tangent of the surface at that point in the surface model, meaning it's just coming straight out of the model. But to do that, we want to make sure that we orient the model properly. And what we're going to do is to tell it which way is flat on the ground. So we're going to pick essentially places that are on a plane. So the easiest thing, we need 3 points. So the easiest thing is going to pick like 3 of the corners of this pedestal. You know, I would pick the bottom corners, but they seem a little less, well, we could, because they don't have to be the corners. They can just be in the crevice over here. And we actually have a tool over here in the menu that lets us do that, which is this pick 3 points. It looks like this triangle. And so we can use our mouse to navigate to where we think we want to do this. And so let's just put one down there. And let's see if we can see a good other point over here. And you know, the more you have them spread out again, the better it's going to be. Somewhere in that crevice there. And now we are oriented. And you can see by default we are looking straight down at it. And now we can use these standard views to very quickly change the way, you know, which direction we're looking at. And again, let's just put the center of rotation somewhere sensible so that when we move our view, it's moving like so. Front, back, side, bottom, etc. That just helps us navigate everything. And you can go ahead and save that, just overwrite that one, and it should be fine. So everything is looking pretty good at this moment. Now we want to compute our normals. So we're going to go to edit normals. Oh, we have to make sure we have that selected. Edit normals compute. And we're going to change the radius. We're going to hit auto. So it's going to figure out exactly the distance it needs to do over here. We're going to click the use preferred orientation where Z is up. Okay? And we're just going to hit OK. And now the normals are computed, and we will actually get shadows kind of looking like it. You know, so you kind of see the normals over here. That's the octree segmentation that it did. Okay, so this is all looking pretty good. We're at a point now where if we wanted to mesh, we could mesh at this point. I'm not going to show you the meshing because it takes a lot of intensity, and frankly it's a little bit extraneous to the project that we're trying to do. So instead I'm going to show you how to compute the statistics. So first we're going to go to Tools, Other, Compute Geometric Features. We're going to calculate surface roughness, the mean curvature, also Gaussian curvature, and why not, and then the surface density. And the rest of this, you know, they're more esoteric. We're just going to click OK, and as it goes along, it'll do them all. And now in the scalar fields, we actually have a whole bunch of ones that we can choose from, and we can now color based on those scalar fields that we just calculated. Surface roughness, mean curvature, Gaussian curvature, and surface density. So, and again, you can look at the histogram to see that the hotter colors are denser points, right? And finally, what you can do is when you have each of these scalar fields selected, you can go to either Edit, Scalar Fields, Compute Stat Parameters, leave that intact, and then you get some, you know, like a regression curve against the histogram for that one, or you can just go back to the Edit Scalar Fields and just look at the histogram and you'll get how many values, and they're basically the spread of the data, like the most common values, etc. And then to get those things as actual exported numerical values, we're going to go to, making sure we have this thing highlighted, Tools, Batch Export, Export Cloud Info. And here we're going to do full cloud stats. And it's a CSV file, although it'll be semicolons, I believe. And that little file, which is in here, we can then open up with our spreadsheet program, which my computer will take a little bit of time to, for whatever reason, to open the program. Okay, so we just have to make sure that we choose the semicolon as the separator and click OK. And here we go. So we have the X, Y, and Z's and the number of points, and the scalar field reflectivity, number of valid values, the mean, the standard deviation, and the sum. Then we also have every other scalar field over here. So we just have to remember that roughness, and then mean curvature, the average mean curvature is 0.6, the average roughness is 0.182. So this is calculated across the whole statue, and the mean surface density is somewhere in the realm of 95,514 points per square meter, which is pretty good. So those are some quantitative values that we can use later on when we're comparing the other mesh that we're going to bring in next, which is the photogrammetry generated mesh. So at this point, that's part one done, and what we would do next is you can optionally follow the directions for trying to create the mesh and texturing it, or you can skip those and move right along to comparing the LiDAR cloud to the photogrammetry cloud. So let's go ahead and bring that photogrammetry cloud in, file open, and we are going to go back to our 3D data, and now we're going to go into the photogrammetry, and it is an OBJ file that we want to open up, and this one will just bring it all right in, and you will see right away that it puts it off into a different area, because these are now no longer the same sensor. They're not in the same coordinate reference or coordinate origin system. So let's hide our LiDAR one, and let's go ahead and deal with this photogrammetry model. So if we zoom in on it a little bit, we can actually see our statue is over here. And so the first thing we want to do, we can put the point of rotation in the middle of that statue so that we can kind of like maneuver this stuff a little bit better. And what we can see is actually we're looking at it from the bottom. So we have to rotate it completely over to the top. Now you can start to see the statue itself. Okay, so there we are. Now this is like taxing my little computer here, so I'm going to try and look straight down on it, and the first thing I'm going to do is highlight the model, and I'm going to segment out the statue, making sure that I give just enough clearance to get all around it and not more. So segment, looks good, and then just double check that that is the one that I want to delete, and here we go. I'm going to go ahead and save that into here in a new folder called cleaned, and I'm going to do initial clip, and we're going to go ahead and save that as an OBJ. Now in this case, we have a fully textured mesh, but we do have some vertices which are in there as well. So you can choose to display just the points like so, and they're actually textured points, which is a little bit weird to know, or you can instead continue to look at it as like fully textured mesh. But it will kind of mess with your eyes a little bit because you'll see it more realistically, you know, the details a little bit more realistically than they are because of that texture. So the next thing that we need to do actually is to align the two clouds so that we can actually compare them together. So we need to get them to be registered, co-registered with each other, and that is super important to be able to do that. So let's open up the other one and zoom out until we can basically see it. And what we need to do is I want to stick the point of view over there again, and making sure we have this model, we need to move the guy. So let's click this translate rotate tool, and all of these things are going to be checked. And now here we're actually like physically moving the thing, and we need to, like, because you saw how it looked like I actually moved it over there. Well, I didn't, right? So you're gonna have to like play around with this multiple times until pausing and moving until they're kind of like actually on top of each other. And it's quite confusing because it depends on which way that you're looking, right? Okay, so maybe if I go all the way this way, and so I'm right clicking to actually drag it and move it, and it looks like I'm getting close in space, so I'm going to right click and drag and move it again, and now I'm getting real close in space, and I'm getting even closer. Look at that. Okay, so now I think finally I am pretty much right on top of where I want to be. Okay, so now I'm going to recenter everything, and actually what I want to just check box, and it is now reoriented, and now I want to sort of recenter on one of these things and move them closer into the center over here so I can actually see which way I need to go. Let's go ahead and select the one here and get a nice, you know, view of it. There we go. Okay, so here we go, and I want to be looking, just for my brain's sake, I want to be looking right at the front of it. There we go. Okay, now let's go ahead and keep moving our one. So if I left click it, now I can like rotate it so that it is sort of like facing the same orientation. And now I can right click and move it up there, and I can pause and zoom in on this and see how we're doing. Okay, it would be a lot easier if I could somehow recenter this. Okay, let's see if I can get this guy in there. Again, this takes significant effort to be able to do it this way. Okay, so let's just call that pretty good. They're close enough now where I can do the point pair matching. That's all I really wanted to do. And so now what I'm going to do is to select them, holding the control button down so I have both of them. Go back to my tools, registration, point pair picking, alignment, and I'm going to make sure that the model segmented is to be aligned. That's this guy over here. And then we'll click OK. And so now we're just going to do the exact same thing that we did last time. So we're going to zoom in on the statue, and we're going to pick corner there. And we're going to zoom in on the other one. And pick that same corner like so. And then we're going to pick the other corner. And then go back. Again, we have to have 3 points to be able to roughly align them. And again, they don't have to be perfect. They have to be close enough. Okay. And then I'm just going to pick this last one here. And then we should be all good to go once I get zoomed in enough on this. And give me 1 second here. Okay, so that should be aligned, roughly aligned. It looks like that rough alignment did not work out pretty well, so we might have to add 1 more point or refine one of these points. So let's go ahead and take a look at that. Okay, so it's looking like my A1 is not very good, so let's go ahead and delete the A1 point. Oops, I didn't want to do that. So let's look here. Let's try and do that again. Pick that point there, and then pick this point over here. Should be roughly the same. And let's try and align it. And of course, we've got even worse alignment now for some strange reason. Let's try that again. Let's just start from scratch, okay? I'm going to hit pause just because you don't need to watch me do this, and then I'll come back once I have all the points clicked. Okay, so I did that off camera, and the mistake that I made was that I got the right points in the right place, but I forgot to click the adjust scale button before I hit align. Because again, these are not on the same reference system, even though they're both trying to scale, to actual real-world measurements. The LiDAR is a little bit better at doing that. It's more calibrated than the photogrammetry. So once I clicked that, then I could hit align, and everything looks good, and now I can hit the check mark. And at this particular moment, I can go to Tools, Registration. Let me just make sure I have them both selected. Tools, Registration, Fine Registration. And I want, in this case, swap them because I want the, the model segmented one to be the one that's aligned, the photogrammetry one. And here, I'm going to keep it at 80% overlap. Should be enough to do it. So let's see what happens. There we go. Very nicely aligned. Click OK. And here we have them right on top of each other. Maybe not perfectly aligned, but probably could do a little bit better if I spent a little bit more time making those initial registration points better. We can try actually one more round of that fine registration, and yeah, let's try and do that one more time. Maybe we up that to 90% overlap and see what it does. It may have screwed it up and I have to go back and do it again, but we'll see. Alright, I think that is much better. Alright, so I'm going to try, that little number there is a little bit of a magic number. In this particular case, increasing it was the right move. So we're definitely much better registered than we were prior to that. Okay, so at this particular moment, I want to save this one out as registered. Okay, so now we won't be able to lose that one if we do it again. At this particular moment, what you will do is go back in to the statistics. Oops. You may have to, let's just see real quick. Tools. Yeah, you have to select the vertices. specifically tools, statistics, no, where is it? Hold on, let me look at my writing down over here so I tell you the right things. Select the vertices, and, oh yeah, it's tools other, compute geometric fields. So the same ones are still checked, so we're going to save those. And then the other thing that we are going to do is we are going to calculate the difference or the deviance between the two clouds. And you may want to spend some time cleaning up the photogrammetry cloud, like for example removing that little like tree with the segmentation tool. So let me just do that real quick so that I can sort of show you a little bit better what the results ought to look like. And we can just see which one is, oops. I guess it's this one. Oh, I had the vertices, that's why. So if I do this the right way, let me just do that the right way. Clip this guy out just the way I did before. Okay, so now you can see that those are the ones that you want to delete. Bye-bye. Okay, so there we go. At this particular moment, our scalar fields are the same as we just did. Everything is the same except I clipped out that little bit. So now we can calculate the difference between the two clouds, which is what we really want to know, is the distance between these two. So what we were going to do is to go to Tools. Let's select both of these things that we want to compare. Tools, distances, cloud to cloud distance. And in this particular case, it's going to be the difference between the photogrammetry cloud and the LiDAR cloud. So actually what we want to do is to maybe select it the other way. Tools, distances. No. First, I select this one and then that one. Tools, distances. There we go. So the reference is going to be the LiDAR and the compared will be the photogrammetry. And we're going to take a look at what we want here, and everything should be left alone here. Just hit compute. And it may take a little while to do it, but then click OK. And somewhere in here should be a new scalar field, absolute distances cloud to cloud. And so that's the color that we're looking at now. And here, once we have that, we can go to Tools, Batch Export, Export Cloud Info. And I'm just going to put pg cloud stats.csv, click Save. And when I open up those things in my spreadsheet, and again semicolon as the delimiter, I will have all of those stats in there. And I will also now have the absolute deviation, so the difference between the two clouds, the average distance in millimeters, I think. So what we can do is now compare the values. So for example, surface density over the photogrammetry, the average is like 10,577 per square meter versus 95,513. So we know which one's denser, and we can also look at, for example, the surface roughness of this, 0.0018 versus the photogrammetry cloud is surface roughness is 0.0201, so a little bit rougher of a surface all in all. The LiDAR is doing a little bit better, but the photogrammetry cloud is pretty good. And that will take you all the way through everything that you need to know for project 4, except for the rendering and of images, which is pretty straightforward. If you follow along in the text file over here, you can go into the display and change the lights and the shading, and then change the color schemes, etc. And then you can go to display and find the render to file setting here, and you can go ahead and change the type to JPEG or something like that. And let's just make a renders, and then you'd give it some sensible name.jpg and click OK. And then all of the renders will be in there. Of course, I did something wrong here. So if that doesn't work for you, you can always just use your print screen function, which I have over here, which is good enough for most of what you need for the project, like so. And then you can save it to your screenshot stuff. So this has been pretty long already, so I'm going to stop at this particular moment.